Okay, show that the average value is the same as that over that interval. Okay, so first let's get the average. So that's 1 over b minus a integration of f of x dx. Now let's look at the other interval. So that's 1 over b over, so I'll call that a. So 1 over b over c minus a over c integration f of cx dx. That's equal to c over b minus a integration of f of cx dx. And I'll take the c over here. And I'll say let u equal cx. So that means du dx equals c. So du equals c dx. So then the integration becomes 1 over b minus a integrate f of u du with the u limits. So we'll say u1 and u2. So if u equals cx, then u1 would be c, and then I should have written the limits in here. Sorry, that's a to b, and then that limit there is a over c to b over c. So using the u variable, the limit would be cx, and x is a over c, and they cancel. And likewise, u2 would be c times b over c, and they cancel. So then the integration would be 1 over b minus a to b, f of u du, but that's a dummy variable. You can change it to 1 over b minus a to b, f of x dx, which is what we said at the beginning, which is a. So it's the same. 314. Find the area under the graph between 0 and x. Okay. So that's the integration between 0 and x, where a is a positive, and I assume x is a positive as well, although it doesn't actually say that. T over 1 plus t squared a dt. A is a positive. I'm going to assume that x is a positive, but it doesn't actually say it. But it should really say x is more than 0, I think. I'll assume it's not a big deal if we don't, because of the symmetry. It would just be a sign flip if x is negative for the area, so it's no big deal. Okay, u equals 1 plus t squared, so that means du equals 2t dt. So I'll put a 2 here and a half here. So that becomes a half integration. 2t dt is du over u power a, and that would equal a half integrate u minus a du. So that would be a half, and this is why a is not 1, so we don't get log. Increase the power by 1, divide by the new power. So that would be a half. U in u is 1 plus t squared 1 minus a all over 1 minus a 0 to x. So that would be 1 over 2 1 minus a, and then I'll put in x, so that's 1 plus x squared power 1 minus a minus, and then if you put in 0, you'll just get 1 like that. Okay. Now, when x tends to infinity, Well, I could change this into 1 over 1 plus x squared a minus 1. And I kind of think they meant to say perhaps a is more than 1 rather than more than 0, because you want this to be in the denominator with a positive power. Because the limit then, if x goes to infinity, you see this would vanish. Yeah, and you see if a is more than 1, then I could put that would make this negative times a negative, which is positive. So then the limit would be 1 over 2 times a minus 1. So I think it should say a is more than 1, and it should also say x is more than 0. Let me open up my software, you see. So it's t over 1 plus t squared power a. T over 1 plus t squared power a. And we're integrating from 0 to x. I don't think. Oh, right. That kind of is looking a bit like what I got. Tx, although I didn't get an x on the outside though, and I got a minus a. So are they doing some serious simplifying here? Oh, they must be, because you can multiply in don't know. Limit. Oh, hang on. Okay. There we go. 1 over 2 a minus 1, but multiplied by the minus 1 would flip that around. So that looks good. And then 2 over 1 minus a. And then that goes on the top with 1 minus a. Yeah. And then we'll put the x now. Oh, how do you put infinity? The inf. Yeah, it's not sure because the a. So I do think a needs to be more than 1.